So let me actually start this part of the demo, and then Summer will join me in explaining everything. So here we have, let me start from scratch. Here we have a Django application. Well, it's not so evolved, even though I think the content is really awesome. But the idea here is to think, okay, let's imagine we're in a situation where somebody or some tool told us this page is slow. So we just know it's slow, but we don't know why. And that's precisely what Blackfire is going to be telling me as a story. We will measure exactly how this page is loaded, so what code is executed in the backend, so that we can display this. And for this, there's actually different ways for you to start profiling with Blackfire. The two most common ones are going to be the browser extension. So if you're working on a web application, you can browse your application and then decide, okay, I want to profile this page. So it's just a matter of clicking on the profile button. This is also something that you can do with the command line. So we have Blackfire command line where basically clicking on that button or typing Blackfire curl and the URL of the page is going to be just the same. You can understand, of course, doing that with the browser extension is just making things very user-friendly. Working with the command line interface is going to be more accurate, as you will be able to profile some GET requests, some POST requests, whatever really makes sense. And of course, also some scripts on the backend, if that makes sense for you. So let's stick to clicking on the beautiful red button for now. And here it starts. So now what we have done is that we started the Python request again, and we added, just for that request, the Blackfire instrumentation. As you can see, it's taking a bit of time. We actually do the profiling 10 times, and then we aggregate and average the data so that the results we show you here will be more reliable, more reproducible. So if I do again the measurement, it's going to be it should be very close to the 838 milliseconds that we see here. There's then, so you can see indeed the wall time being the overall execution time on the server for the Python code is 838 milliseconds. The input output, so time that we waited for something to happen outside is 184. This is the CPU actually working. This is the memory, so how much memory we have used. And here you can see the number of SQL queries and the overall time it took to execute all of those SQL queries. In Blackfire, there's two dimensions two visualizations to browse through the profiling data. There is the timeline and there is the call graph. Let's have a look for now at the call graph. So the call graph, as it is named, is really representation of all of the calls that have been executed to, in my case, load the page. Starts with main, then it starts loading some Django components until the end. Now, what really is cool about this view is that it will show me what are the hot paths in my code and what are the nodes that on their own consume more than the rest. That's the difference between what we call the exclusive time and the inclusive time. So the inclusive time is the time spent within a given function call, for instance, this one. And the exclusive time is going to be, inclusive time is time spent within that function plus everything it has been calling. And the exclusive time is the time spent only within that function. So here, for instance, render, it takes 6 milliseconds to execute, but including everything it calls behind, it's costing 827 milliseconds. So we can then, have actionable metrics to figure out if there is something that we can do about it. Maybe, looking at vendor annotated, we see it has been called 500 times. So maybe this is the place where we should start looking. And maybe not. Again, it depends a lot on what the code is doing. Maybe this is intentional. Maybe there is nothing I can do about it. So the call graph is really available on all of the dimensions where it makes sense. When it comes to SQL queries, you're going to have the list of SQL queries with the number of calls for each of them and the overall time they have been consuming. We actually anonymize. So here, when you see question marks, that is because we anonymize all SQL parameters by default so that you actually have no problem with privacy and confidentiality. This is also why we're fully GDPR compliant by default, because we just don't collect any end user data. Now, to get to the timeline, which is actually going to be the best tool in my situation to figure out what is really costing me a lot in performance, the timeline is here, the overall execution of the request over time. So from the start to the beginning, with all of the calls that have been executed, which are stacked, and then the blue curve here, which is the memory usage. And that's where Sumer is going to explain us exactly what is going on here in the code and what we might be able to do to improve it.
Thanks, Chris. I will try my best. So before moving further, I just wanted to say that it's a very simple Django application that we have here. It's just, I have added hundreds of command models to the database, and just when we go to the endpoint, we are just querying the database and just print out the command model. And inside that model, we have a foreign key to the user. So every time we print out the command model, we just print out the user, and which makes the n+1 problem. I think it's a classical problem we have with SQL queries, and it's just like when you have a foreign key in a model, and when you print out that model and the foreign key, it just goes and makes another SQL request, and that's just what you are seeing here. So the green line. The green line here is the actual Django template engine's render function. And inside that render function, you can see that lots of calls are happening. And what you can see that it takes 100 to 800 milliseconds. It's trying to render the page and going to the database, coming back, going to the database, coming back. And what you can see is that we have hundreds of times it's going to the database. So we obviously have some kind of problem. It also can be seen from the SQL queries, obviously, as well. And to fix this problem, maybe you know, but maybe you not, but Django has a select prefetch statement. So when you do the prefetch on the foreign key that you want to query, so it will just prefetch all the things within the query and caches them. So when you just iterate over the commands, it will just use it from the cached version. So if we can go to the fixed one, Chris, we can maybe, yeah.
Yeah. So we will spare you the moment where we change code. Yes, this demo has been staged a little, at least. The profiling is live. The code was done before. But by the way, we're actually deploying that on Platform SH, which is a hosting solution we really enjoy working with. As you can see here, I actually have a branch that has been deployed with my code, and that's the whole promise that they have, is really showing, well, giving the possibility to do continuous deployment. So anytime you have a Git branch that you commit to, you can map it automatically to a new environment in Platform SH that is going to deploy the app, so you can do any sort of testing on it. So here indeed, Sumer has well fixed the n+1 prom, hopefully, and it's deployed on this site. So we will be able to measure again so that we can figure out if we actually improved the performance of the code or not. So let's do the profiling. You can see already it's going a little faster than it did before, and we can see the numbers as well. So 300 milliseconds, if you remember correctly, we had more than 800, I believe even 900 milliseconds. Now, as much as I could go again and look at the call graph and the timeline, so let's do it, and we will see already the difference, as there's going to be a much more simple timeline here. Really exciting feature of Blackfire. is to enable to compare two profiles. So this is the first measurement we did with the performance issue, the N+1 issue. And this is where we hope we have fixed the issue. What really is key when you deal with performance is you must measure it. And even when you believe you made an improvement, you should actually check it. So measure again and compare with the previous measurement so that you really know what you have done or not. As a matter of fact, I can see in terms of wall time, there is a gain of 63 milliseconds. Now, yes, it's a trade-off because it requires more I/O. Maybe actually, for whatever reason, I can come out to the solution that, well, this is not an acceptable improvement on my end. I didn't want to touch I/O. Well, in our case, I guess it's really totally fine. But the call graph here is also going to show us in blue everything that is a performance improvement, and in red everything that is a performance regression. So here I can scroll down there and I can see indeed that doing less of those SQL calls did have a very positive impact on the SQL compiler. So I guess this makes a lot of sense. We can also here see that, well, actually all of the calls we did here are now totally gone. That one as well. There is one new one, but that's expectable. And yeah, so that's really about the basics about profiling Python code with Blackfire. This is everything is fully available as you have seen now. Yeah, we are still working hard so that all of the features we offer on PHP can also become available on Python. Sumar, if you have anything you want to add about it.
Yeah, there is a question. Did you see it in chat?
Oh, let me open the chat.
Mm-hmm.
So do I need to modify some parts of my application for Blackfire to be able to instrument it? Or do I change the way I start things up for Blackfire to instrument the code?
I think I can answer it if you want.
Go ahead.
So yeah, the only thing that you need to instrument is currently it's just for Django, it's just installed as a middleware. But for other things, it just works like Yappy. If you have, I'm not sure if you have used Yappy, but it's just you need to import the Blackfire prob SDK and you just start. And when you call start function inside it, it will start the profiler and it will deterministically profile all the calls you have made from after that call. And the second question is, can it measure memory allocations in native C code? So it should be, I mean, if the native and C extensions are using the normal memory manager, it should be because it's using the trace malloc memory, and as far as I know, the memory allocations inside that is just hooking into the memory manager of Python. So in theory, yes, it should measure memory allocations in native and C code. But if you are using another memory manager like malloc or your raw malloc and not using the Python, of course it cannot measure those.